This video is going to go over another type of rotation. These are rotations on an object or a figure about a point. So in your notebook, you should have an image that looks very similar to this, or that is exactly like this. And it is a picture that's made up of three different shapes. So what I would like you to do is pause the video and find highlighters and or colored pencils or something. But what we're going to do is we're going to outline the three shapes. So we need a color for the square, a color for the triangle, and a color for the hexagon. So if you don't have that handy, take a minute, pause, and then come back once you have that. Okay, so now I have some highlighters. I am going to take a blue highlighter and I am going to highlight the square. So that square is JKLM, and I only want the outside. Now I'm going to take an orange highlighter and I'm going to highlight the triangle. That's triangle ADG. Again, just doing the outsides. And then finally, I need to do the hexagon. For the hexagon, I'm going to take a green highlighter. And so that's going to be the outside. So that's the HIBCEF, and highlight the outside. I like using the colors because it helps our eyes distinguish what shapes. Otherwise, the lines start overlapping in our head and we start to get confused. So notice that we have point O, and I'm going to put a pink dot here around point O. And so if you look at my directions, it says we're going to find the rotation about O. O, that center, is what we're calling the turning point. So essentially the idea of the questions down below is if I were to stick a nail down through point O and start turning this notebook, the set number of degrees that's written down below, I want to know what letter would I land. And truly, what I want you to envision is if we had a square on top here and we rotated it, if we had a triangle on top and we rotated it, and we had a hexagon on top and we rotated it. So say I had three different figures. If I could leave one stationary and then rotate the one on top, what I want to know is what it becomes. So I did take a moment and use some patty paper to trace these so that I can demo what's exactly happening. So I'm going to start with the triangle. And so the idea of the triangle is this, that if I'm taking and putting a point through O, I want to know if I'm pointing, and remember all rotations need to be counterclockwise. So if you still need to remember that, give yourself a reminder that all rotations are counterclockwise, unless we otherwise note. So that means we're going to always turn towards the left. So when I think about this triangle and I'm rotating, what I'm asking you is if I have this pin through point O and I take my patty paper, when I rotate this triangle, A is going to come down here and land where G is. And I apologize, my triangle's not the best. It's supposed to be equilateral, but it kind of got stretched out in copying. And then when this rotates again, D comes down where G is, G goes up where A comes over where D is, and then when we rotate back, here we are. So this is supposed to be equilateral. Like I said, it's kind of gotten stretched in my copying, so it's looking a little taller than it should. So let's think about that triangle. So I'm going to write triangle over here. So what we know about a triangle always has inside of it 180 degrees. We know that when I take 180 and divide it by 3, that means each of these equilateral triangles should be a 60-degree angle. But that is not talking about the rotation. That's talking about the individual angle sizes. When I want to think about a rotation is going to be, we have a full 360 degrees is a full loop around. But since I have a triangle, if I divide it by 3 movements, that means each rotation is going to be 120 degrees. So for that triangle, 360 is an entire rotation, and because I can rotate this 3 times, A to G, A to D, and then A back to where it was, 360 divided by 3 gives me 120 degrees. So that means anytime I move from A to G, that's a 120 degree movement. And where does that 120 degrees come from? It comes from the angle that goes back to this origin and between letter to letter. Down here, there's your 120 degree angle, and then back up here, there's your other 120 degree angle. Now let's talk about the square. So for the square, that's my blue one, if I'm doing a rotation, we're going to take that 360 degrees, divide it by, for a square, that object is moving from J, is moving to, get my paper, to M, and then moving to L, and then moving to K, and then back where it started from. Thankfully, the square looks a little more on size. And so when I take 360 and divide it by the 4 different possible movements, that means each rotation is going to be 90 degrees. And then finally, for our hexagon, the hexagon has 6 different angles that we're rotating between. So I can become H, F, E, C, B, and then back to A. And so when I do my rotation, if I take 360 and divide it by the 6 possible ways I can rotate it, each is going to come out to be a 60 degree rotation. And again, that comes from the angle between I and B, the angle between I and H. And so once I have how big each one is, when I come down here to the bottom, it becomes a skip counting kind of scenario. So first off, you have to determine which shape is rotating. So when I say 120 degree rotation of B, when I find letter B, I notice B is on the hexagon because it's green. So therefore, I'm not worried about the triangle or the square. I'm worried about that hexagon. And every time it moves 60 degrees. So if I want to go 120, what I'm asking for is if I place this hexagon in place, I watch where B goes. When it rotates 1 turn, that's 60. When it rotates a second turn, that's 120. So B lands over here, which means B will land where letter H is. So 120 degree rotation of B would land you at letter H. Number 2, this time we're going to rotate L. L is on my square. How do I know? Because L is in the blue shape. So with my square, every time I turn it, I turn 90 degrees. So if I'm watching my rotation, if I'm taking and rotating my square 90 degrees every time to go 270, if I take, that's 90, 180, 270. And that's because since this is on the square, that means I'm rotating every 90 degrees. That means I need to move 3 spaces. So 270 divided by 90 means I'm going to move 3 spaces. So L became 1, 2, 3. L became M. Let's do one of the ones that's on a triangle. So I need an A, G, or a D. So here we go, number 10. So I want to rotate 240 degrees. I want to rotate A. So A is on my triangle. My triangle, every time it turns, is 120. So if I follow where A is, when it moves 120, that takes it to G. Another 120 is going to take it over here to D. So A is going to become D. If you don't have the patty paper and you don't have that available to you, you don't need it. You can look up here and go for it. because A is on the triangle, and the triangle rotates every 120 degrees. If I take that 240 and divide it by 120, that tells me it's going to be 2 rotations. So if I take A and move it 2 rotations, and I'm only moving along the orange shape, 1 would be G, and 2 takes me to D. So that's another way to do it. Let's do one of the segments. So let's do number 4, 300 degrees of segment IB. So segment IB is a side of my hexagon. So that means this time I'm thinking about following this entire side. Well, remember, a hexagon moves every 60 degrees. So when IB moves and becomes HI, that's 60. When it moves here and becomes FH, that's another 60, so I'm up to 120. When I move it another one to become EF, that's going to be 240. And when I move another one, sorry, I think I screwed up my numbers there. I'm going to just try to crop that out. Let me start that one again. So again, I'm taking this IB, I'm rotating it 300. So for 60, that would be 60, 120, 180, then 240, and then finally 300. So IB would rotate over here to become BC. And again, another way to do that, since IB is on the hexagon moves at 60-degree increments. So 300 divided by 60 means I need to do 5 movements. So taking IB and moving it 5 movements. So this would be 1, this would be 2, this would be 3, this would be 4, and finally this would be 5. So IB would become BC. Because it's a segment, the order doesn't matter if you wrote CB or BC. You have the same answer. So why don't you take a minute and try these others, see what you get, take a pause, and then come back to me. So hopefully you took a minute and tried those. So now let's check your answers. So number 3, 60 degrees of C means I'm going to move 1 to the left, which takes me to B. Or I'm sorry, 60-degree rotation of E. I moved C. I was looking at the answer. 60-degree rotation of E takes me to C. Number 5, 120 rotation of FE. So FE would be 1, 2 60-degree rotations would get me to 120. So that would be CB. For JK, I'm moving 180. So that's on the square. So that's 90 plus 90 takes me to LM. For C, 240 degrees, that's going to be moving at 60-degree increments. So C to B would be 60, 120, 180, and then 240, which would take me to F. 360 of IB is a full rotation. So IB comes back to where it started from. And then finally, 90-degree rotation of L is 1 turn, which takes you to K. So now you should have both done the rotations from yesterday or previously, and rotations on a graph, and then rotations on a object.